Alrighty, here's the second major part of this build. It's actually going to be getting our motor sorted out, and we have officially bought the motor. As you can see here, it's a 60 horsepower Flying Scot, I think from the mid 1970s. This is what you would have seen on the back of one of these boats right there. I can't really figure out if it was like an 80 horsepower or 70 horsepower that went on the back of these boats. I bought this from a guy who said he also had it on the back of a Belmont, so not really sure, but it sounds like it should push us fine. So this is the engine we bought here. Let's pop the cowling off, and we'll take a look at the old engine that we're gonna throw out. Popping that off, we see we got a nice, oddly enough, three-cylinder engine, three-cylinder inline here. Really strange, but you know, whatever floats your boat, no pun intended. And our plan here is, I've already taken some parts off. I took the starter motor off. Got the starter disconnected. We're just gonna take that off. And this right here was the kind of cover for the flywheel. It's a really kooky looking engine, and we'll have a lot more to run through as we take it apart. But the plan is we're gonna pop the whole engine off, just take it off. Whatever's wrong with it, seized, I don't really know what's wrong with it. We're just gonna throw it out, and then we'll be left with the rest of it. And so I think the drive shaft, which, you know, if you have your diagram of an outboard motor, you got the engine up here, and then the drive shaft kind of runs down here into what's called the lower unit down here. And it's like a little differential where drive shaft is spinning here. It's a 2-to-1 ratio, and it goes to the propeller drive, and that drives it that way. I can explain that more as the project continues. So we're just going to continue popping this motor off, and then the idea is that we'll be left with everything except for the engine, and then we'll take our electric motor and just put it right where this engine used to be, and hopefully that does it. All right, we took off one of the engine cover plates here, so you can see the pistons in there. Now we're going to take off the carburetor and get more of this engine disassembled. All right, so we've taken all of the relatively easy stuff off. Here's the box where all that stuff is. That is literally just carburetor. Used to be out here, intake manifold. There used to be the alternator here. There's the old flywheel that went up there. We also took the head off, and there's you can see a three-cylinder, a straight three pistons sticking out of the cylinders there. Seems that this weird design with the top is a 2-stroke design, and you can actually see in here in this area, I can't get it with the lighting, but you can see that the cylinders are in there. So now the hard part is going to be figuring out where the mounts are, because the manual doesn't really state it that well. So we're somehow going to have to take basically the skeleton of the engine off, and then we'll be able to reach the drive shaft when we'll be done. But we finally got the engine off of the head there. All right, we got the crankshaft undone. Dude, all these bearings are gonna fall out. There's the crankshaft. Gorgeous. And then in there is the pistons. Okay. Okay, there's one piston. Hella cool. All right, force that one out. Come out that way, just pop out the head. Right there. Let's see if that fits.
Oh, this one's coming.
Is that one coming? There's the head.
Yeah, look at that.
Cool.
That's cool.
Oh, these are so weird. I think because they're 2-stroke, they have this really weird head. Because I think with 4-stroke, it's a flat head. Yeah. Fire! We got it disassembled. All right, we got the engine taken off here. It was a lot harder than we thought, which is, I think, the common theme for these kinds of projects. But as you can see, we popped it off. Here's the top of the drive shaft right there. And you kind of, well, you can't really see anything. But there's, looking down, you can see the drive shaft back there as it descends into the darkness. And then yeah, we had to take some of these mounts off. Yeah, the clutch is right here. It's this thing. Yeah, let me see if I can. Yeah, go for it. I don't know if it's gonna. It might be on.
There you go.
There you go. I didn't see that's one of the forward gears. I don't know. It's some gear.
That's reverse.
Yeah.
Reverse is a little messed up.
All right, so we just removed the lower unit from the engine, or I guess the mount. I don't know. From the I think that's the middle unit. I'm actually not sure if that's the middle unit or if that's the middle unit. I think that's the top unit. But we got it out. We're gonna just take the skin off here so we can actually get to the lower unit down there, and we'll check out the gears, make sure they're not ground up, and we're gonna do some repairs, and I'll explain that later. All right, we got the middle unit off, I think. Some oil in it, and now this gives us the lower units, or most of the lower unit. I think this is specifically the lower unit down there, but as you can see, this is the beginning of all that gearing. All right, so we got the lower unit. I got this figured out, by the way. Lower unit down here with the gearbox or just the few gears, and this is the water pump housing. So this would be for the old coolant. This is the disassembled water pump we took out of here. It's connected to the drive shaft, and then this part comes off, and you pop it out, and then here's the end of the drive shaft, and in here is that's the gearbox down there. All right, so we got it disassembled. Here's the lower drive unit taken out. As you can see, you got some, can't really figure out, this is probably reverse, forward, and then the dog is right there. You got some couple of bearings on either side, and then there's just the cap for the lower unit. And yeah, it's about a 2-to-1 ratio, I think. So this gear is twice the size of that gear. It helps kind of distribute torque a little better. Okay, this is shaping up to be a pretty short video. We were doing a lot of huffing and puffing and not a lot of filming because we were just trying to take it apart. This is a perfect time to explain why and how and what we're going to be doing with the engine. So the first question of why is pretty simple. It's because it's cheap. If I did have a ton of money, all the money I could spend in the world, well, I'd probably just buy an electric boat. If I actually wanted to build it, I would be able to design this more optimally for an electric motor, just because there are some parts inside of this engine that are just not designed super well. For example, the gearbox isn't really designed exactly for an electric motor, and kind of stuff like that. We're going to try to get around some of these things by designing our own propeller at the very end, after I take fluid dynamics and do some of that stuff in my engineering courses. But yeah, we bought this $80 motor so we can save a lot of money, and we're just going to take the only broken part on it, which is the engine. We're just going to take that off, as you saw. And then we're going to take the rest of the thing apart just to make sure it's all good. We have to change the lubricant for the lower unit here because it's just old. It's been sitting there for at least 20 to 30 years, so we got to change that out. So we're just going to take the whole thing apart, take a look at it. And then once we get the electric motor, we're just going to literally stick it right on top of the drive shaft, and it should theoretically do exactly what we plan to do, which is just turn the propeller and make us go. So obviously, I'll get more into details around the electric motor and stuff as we actually buy it and get to the planning stages. Right now, we're just taking it apart and kind of explaining in simplest terms what's going to happen next. On a very basic level, what we're doing is taking the engine off, putting an electric motor on. The second small kind of immediate issue that's very basic is determining how we're going to change direction of the propeller spin. So basically, our issue is the lower unit, essentially. That's just what it is. So if you don't know, the lower unit is the very bottom part where the propeller is situated, and it kind of looks like this. So the propeller's sticking off this way, and this is the gearbox inside. So drive shaft comes down, and there's this gear right here, and there's this thing called the dog, and the dog goes from side to side. It's got 3 sides: drive, neutral in the middle, reverse, or sometimes the other way around. And it basically engages these gears so that you can switch directions of the propeller. And this is all because, as everyone knows, engines only turn one direction. So for a century now, to get around this, we have put gearboxes, essentially, which is what the lower unit is. And so there's a forward gear, neutral, reverse. That's how you switch directions of the propeller. However, as I've taken this engine apart, the clutch has proved to be very funky and kind of difficult to work with. It's old, it's corroded, it's kind of jammed. I don't think I can even get new parts for this. If anyone knows, let me know. But I don't think I can get like a new clutch part. I'd have to kind of lubricate it and machine it myself. And also it's mechanical, it's not hydraulically controlled, so that would be a little complicated actually to get it run all the way back to the cockpit and have to do that mechanically rather than electronically with a hydraulic pump. And that would just suck to have to redo this system. Whereas over here with the electric motor, we have just a different way of getting our power, and also a different way that power works. So in an electric motor, the spin kind of depends on which way the current is going, essentially. There are some differentiations, especially when you get to AC motors, which is what we're going to be using, but I'll just keep it in terms of DC, direct current, because that's just kind of the easiest to explain it in. So if your power flows one way, let's say in a clockwise direction, it will turn the motor clockwise. A current going one way will spin the motor one way. If you stop that current and then run the current in reverse, it'll spin the motor the other way. And this is huge because it means we don't actually need like a dog or any sort of mechanical gear shifting. We can all do it electrically, and we only need really just a drive gear and a translational gear that translates this y-axis spinning to spinning about the x-axis like that. And these gears can go either way. As you can see here, these gears have to be opposite to each other, and the dog kind of switches them, and yeah, might lead to some corrosion of the gears. Definitely gonna be harder to put together than if we do this way. This system will be easy. We just set the clutch in drive, which I've already tested. It can go in both directions. And then we kind of just leave it alone. We fill it with lubricant and then just close it up, kind of forget about it. And then when we want to go to our gear shifting, or not gear shifting, direction shifting, we can go into the motor controller and program it to shift current directions. As I said before, we'll get more into that when we actually have the electric motor in our hands. But that's the idea that I'm going after here, is that it'll be actually easier for us to code the motor to run in two directions rather than to have this whole system here. I'm very tempted to do that. However, this system here is not really meant to do this. It's meant to do this job, right? It's only meant to spin one way. So that's kind of the predicament I'm in, is will I break the lower unit if I do this? Like, will there be, will it just shred the gear if I jam it too hard in the other direction? Obviously, we'll be using common safety features that we have on the water that I learned, which is like keep the boat neutral for a couple of seconds before you go to reverse. Don't go straight from forward to reverse all the time. That'll really hurt the engine. But like, I'm wondering if I even just go in reverse, or if we go in reverse, will it just shred this whole thing because it's not meant to go that way? So these are questions we're gonna have to ask ourselves probably in the next video as we put this thing back together. Another important part is the old water pump and impeller that used to run the coolant. So this is the old water pump. It used to, as you can see, there's a hole in it. It slides over the drive shaft and goes on here. Actually, it goes like this. Goes on here, and this little pipe down here kind of comes out the bottom over here and sucks water out. And it sucks it up and into the engine. And as you can see, this pipe over here lines up with this end of the pipe, and there's an impeller in here, this little rubber thing that is turned by the drive shaft, and that's how you pump water. And so as I was explaining before, if the drive shaft is going the other way, we're actually gonna have to get rid of this because it's just not gonna work the same if the drive shaft is going the opposite way. So that's the whole motor as it is now. There are a few smaller parts. So as I mentioned, the pump is gonna have to be redone, as well as there's also no hydraulic lift on this. So the way you get this motor out of the water is actually manually. You have to press some levers down here to pick it up. So we're also gonna make that hydraulic so we can also add some trim on it. But other than that, that is the motor as it is right now. And we'll be putting it together the next few days, so I'll definitely get more video as we start doing that. But yeah, thanks for all the views. That was really surprising on the first video, so thank you for sticking around. I'll try to come out with these at the latest weekly, but most likely every other day, just following our progress. So stick around for next time. We're gonna be putting this together. We're gonna buy the motor and talk about some aspects of putting electric motors together and how they work. And yeah, thanks for watching this video, and I'll see you in the next one.